everyone, and welcome back to exercise number 42 of the SolidWorks basic tutorial series. In this video, we're going to be designing a forked pivot bracket. Now, as always, in implementing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature. Also, we're going to be using many of the sketch tools in creating these fork arms right here. Here we see the schematic drawing for exercise number 42. All dimensions are in millimeters. We have the isometric view. We have a sectioned 3D view here. We have the front view, side view, and top view. Also, we have a question here that reads, what is the mass of this part in grams? And the answer should be provided within a given tolerance. We have a set of instructions. The instructions are self-explanatory and it's pretty obvious. The key takeaway, however, is that we're going to be using a material of ASI 1020 steel in answering this original question. All right, so let's look at the 3D features with component. Immediately, we recognize the fact that the main body of the component consists of two cylinders that are perpendicular to each other. The first cylinder, the horizontal cylinder, we're going to call the primary cylinder. The perpendicular cylinder here, we're going to call the secondary cylinder. In creating the primary cylinder, we're going to sketch out two concentric circles. Basically, we're going to draw the 2D profile right here on the front plane. And then we're going to perform a mid-plane extrusion. We're going to extrude the 2D sketch to an overall length of 150 millimeters, as you can see right here. After that, we're going to work on creating the secondary cylinder, and for that, we're going to have to create a new drawing plane, okay? A new drawing plane that is approximately 100 millimeters away from this center origin right here. So after that, we're going to sketch out two concentric circles again, and then perform an extrusion and set the end condition to up to this curved surface, and that will create the main body for the component. After that, we're going to have to create another drawing plane, this time to create this coaxial boss, in addition to the central board at the top right here. And last I checked, the drawing plane should be approximately 35 millimeters away from the top plane. And for that, after drawing the 2D sketch, we're going to perform an extrusion and set the end condition to up to surface. We're also going to work on creating these features right here on the sides of the secondary cylinder. Finally, we're going to work on creating these fork arms. So the easiest way to do that is actually select this face, this circular face, and then perform a offset extrusion. And we're going to offset the 2D profile of this fork arm basically 20 millimeters away from the surface right here, okay, as you can see in the schematic drawing. After that, the final touches would be to fill out certain edges. Again, we're going to be using a fillet radius of 2 millimeters for each of these fillet edges, all right? So that's our game plan, that's the strategy. The exercise is pretty simple. There's no complications with it whatsoever, all right? So with that aside, let's get started with exercise number 42. Okay, so let's start by creating a new SolidWorks part. Let's set the background to plain white. And let's copy exercise number 42 into SolidWorks. Let's go ahead and make this smaller. Okay, so as I said previously, step number one would be to create the primary cylinder for the component. And for that, we need to draw two concentric circles on the front plane. So to start, select front plane, sketch, let's put this to the side, and then activate the circle tool. And starting from the origin, we're going to draw two concentric circles, 1 and 2. All right? Activate the Smart Dimension tool, and the diameter or the dimensions for these two circles, if we look at the top view, we see that the diameter of larger circles should be 50 millimeters, while the diameter of the smaller circle or the hole should be 30 millimeters. So the diameter of this circle should be 50 millimeters, and the diameter of this hole here should be 30 millimeters. All right. Now press the S key, select Extrude Boss Base, right-click on your mouse, and set the end condition as mid-plane. It's important that we maintain symmetry here during the modeling process. And then go ahead and assign an extrusion length of 150 millimeters. Why 150? If we look at the front view, we see that the length of the primary cylinder should be 150 millimeters. All right, and then select OK. And that completes the primary cylinder. For the secondary cylinder here, we see that it's perpendicular to the primary cylinder, and we need to actually create a new drawing plane that is approximately 100 millimeters away from the origin or the center of these two concentric circles. All right, why 100 millimeters? Because if we look at the side view, we see the distance between this center of this circle and the extremity of this secondary cylinder is exactly 100 millimeters. So go to Features, select Reference Geometry, and then select Plane. All right, here it's going to ask you for the reference plane, so go ahead and just select the right plane, and we're going to offset this drawing plane, this new drawing plane, at a distance of 100 millimeters, and then go ahead and select OK. All right, right-click on this new drawing plane, and then select Sketch, activate the Circle tool, and then from the origin, draw a single circle. Activate the Smart Dimension tool, and we see that the diameter of this circle, this larger circle right here, should be exactly 50 millimeters, all right? Which is similar to the diameter of a larger circle for the primary cylinder. So this should be 50 millimeters. Press the S key, extrude boss base, and set the end condition to up to surface. And then go ahead and select this surface right here. And then select OK. All right. Hide this drawing plane. And now just select this surface, sketch, activate the circle tool again. From the origin, draw a circle, activate the Smart Dimension tool. And if we look at the front view, we see that the hole here should have a diameter of 30 millimeters. So this should be 30 millimeters. Press the S key, extrude cut, set the end condition as up to next, and that will create the hole up to the curved surface right here, and then select OK. So that creates the main body of the component, all right? Step number 2 would be to create the coaxial boss here or protrusion at the top. So for that, we need to actually create a new drawing plane. If you notice that this part involves creating a lot of drawing planes. So here, we're just going to ask us for the reference plane. Go ahead and select the top plane. And we're going to offset this new drawing plane at a distance of 35 millimeters, because if we look at the front plane or front view here, we see that the plane, the topmost plane for this coaxial boss should be 35 millimeters away from the origin of the component, right? So set the offset distance as 35 millimeters, and then select OK. Right-click on this new drawing plane, and then select Sketch, activate the Circle tool, and from the origin, draw a single circle. Activate the Smart Dimension tool, and if we look at the top view here, we see that for this coaxial boss, we have an outer diameter of 20 millimeters, all right? So assign a diameter of 20 millimeters, press the S key, extrude boss base, right-click on your mouse, set the end condition as up to surface, and then go ahead and select this top curved surface right here. And then select OK. Hide the drawing plane, and that creates the coaxial boss. Select this top face, sketch, and we're going to create the hole here that runs along the entire length of the coaxial boss. Activate the Circle tool, and from the origin, let's draw a circle. Smart Dimension, and this should be 10 millimeters. Again, 10 millimeters. If we look at the top view, we see that this hole should be 10 millimeters. All right, press the S key, extrude cut, set the end condition as up to next, and then select OK. That creates the hole here. All right, so now we need to work on creating these features here at the sides of the secondary cylinder. So to do that, we need to actually create a new drawing plane. So go to Reference Geometry, Plane, and we're going to create a new drawing plane that is in reference to the front plane. All right. And it needs to be exactly 35 millimeters away. Why? Because if you see here that the overall distance is 70, and half of 70 is 35 millimeters, right? So yeah, select OK. Right-click on the new drawing plane, sketch. What we're going to do is sketch out the 2D profile for the feature. So activate the Line tool, and very simply just sketch out the drawing, the 2D sketch. Go back to the origin here, and then we're going to create an arc all the way, and then close off the sketch. All right. Select this point and the origin and set the relation as horizontal. Activate the Smart Dimension tool. And if we look at the side view, we see that the length of the feature here should be 25, and the distance between the center of this circle and this edge should be 22.5. So the dimensions are 25 and 22.5. This should be 25, and the length of this edge should be 22.5. All right, press the S key, extrude boss base, right-click on your mouse, select up to surface, and we're going to select this curved surface, and then select OK. Hide the drawing plane, Select this surface, sketch, and now we're going to work on this opening here. So activate the circle tool, wake up the center point by hovering over this curved edge. On this point, draw a circle, activate the Smart Dimension tool. The diameter of this hole should be 16 millimeters. Press S on your keyboard, extrude cut. And if we look at the top view here, we see that the hidden line showcases a cut depth of 10 millimeters. So set the end condition as blind, and we're going to set an extrusion or cut depth of 10 millimeters. Then select OK. Now what we need to do is mirror this 3D geometry to the other side, and we're going to have to use the mirror tool. So go ahead and select mirror. Here's going to ask us for the reference plane or reference surface. Here we're going to select the front plane. As for the features, go ahead and select the extrude and the cut, and then select OK. And that mirrors the geometry to the other side. All right. Now, finally, we're going to work on creating these fork arms. We're going to create one of them and then mirror to the other side. So let's go ahead and start by selecting this face right here, and then select sketch. All right. Activate the center line tool, and let's go ahead, starting from the origin here, draw a horizontal center line. Activate the center line again and draw this time an inclined line. Set the angle between these two lines as 45 degrees. All right, it's set to 45. And the distance of this line right here should be 100 millimeters. All right. Why 100 millimeters? Because we look at the 2D sketch, we see that the length of this overall fork arm from the origin right here, from the center of these two concentric circles, is 100 millimeters exactly. Now, activate the circle tool, and from this point, draw a circle. Activate the Smart Dimension tool, and we see here that the radius of this circle here should be 8 millimeters. So this needs to be 8 millimeters. Actually 16, because we have a diameter of 16, radius should be 8. All right. Select this surface, convert entities, and that will create a sketch for the outer profile of this primary cylinder. Activate the line tool, and we need to create 2 tangent lines connecting these 2 circles. So we have one tangent line, that's 1, and another tangent line right here, 2. Right? Make sure that we have a tangency condition for these 2 circles or 2 entities. So we set this as tangent. We have this as tangent. We need to set this. Okay, so everything is tangent. Activate the trim tool and delete any extra entities. 1, 2, 3. Okay, leaving behind the final 2D sketch. So now we just create the slot opening for the fork arm. So starting from this point all the way to any arbitrary point along this inclined center line, we draw a slot. Activate the Smart Dimension tool, and the length of this edge should be 50 millimeters. All right, and the diameter or the radius of the slot should be 3.5. Again, if we look at the 2D sketch here, the length of the slot should be 50 millimeters, and we have a slot radius of 3.5. All right, now everything is ready. Just press S on your keyboard, extrude boss base. We're going to extrude from an offset distance, and the offset distance needs to be 20 millimeters. Why 20? Because if we look closely here, the 2D sketch of the fork arm actually is at an offset distance of 20 millimeters from this edge right here, which corresponds to the face of the primary cylinder. All right. And we need to extrude this 2D sketch to a thickness of 10 millimeters. Because we look here, we have the thickness of the fork arms is 10 millimeters. Reverse direction and reverse direction as well here. All right. Then select OK. And that creates one of the fork arms. Now we need to mirror this to the outside. So again, select mirror. And for the reference geometry, we're going to select reference plane. We're going to select the front plane and then automatically select OK. And that creates the second fork arm. Now, finally, what we have to do is basically fill out certain edges. So select the fillet tool. And we're going to set a fillet radius of 2 millimeters. Because if we look at the fillet radius here, we see that all fillets have a radius of 2 millimeters. And then just very simply select the edges that we need to fill out. All right. All the way to the side right here. And yeah, that concludes it. That's everything we need. And then select OK. Delete this image, or actually before we delete this image, we need to assign a material of ASI 1020 steel to answer the question of what is the mass of this part. So go ahead and delete this image, assign a material. We're going to set it to ASI 1020 steel, apply, close. And to determine the mass, go to evaluate, mass properties. And here we can see that we have a final answer of 2,676 grams, approximately 2,676, 2676 grams. That is our final mass. Okay, so that concludes exercise number 42. If you have any comments or questions, please leave them down in the comment section below. If you like this video, please don't forget to like and subscribe. I'll see you all in exercise number 43. Until we meet again, bye-bye.